I had you guys just working through some straight law sign stuff. Shh, guys. We had you guys doing a bunch of law signs, and with any luck, it really shouldn't have been all that crazy. So it was all kind of the same thing over and over again. I made sure on the sheet here that you guys did not have to worry about any what we call ambiguous case. There was nothing that you had to worry about with the two triangles. We started to briefly discuss a little bit about that on Tuesday. We'll go into depth on that one today, as well as talk about cosines. Hello. What we got? It's not. It should have been that tough. As long as you know, as long as you're setting it up and pressing the right buttons, you should be all right. What was someone saying? One? There's no triangle. If you get an error through it, it means there's no triangle. Double check, make sure you screw it up. But okay. So, number 2, guys, come on. First thing I always want you guys to do on these, never changes with any style. Draw a picture, label.
Jared says pictures are like too low level.
And as soon as you do that, then write down what you need to find. You got to find angle C, little a, little b. Do that every time for every problem, whether it's law sines, law cosines, right triangles, whatever. That way you know that you've remembered to get every piece that you're missing. Okay, it's a little trick that I always show you guys how to do. This one here is forcing you to find angle C first because it gave you 2 angles. So 121 and 23 is 144. Back that out, I believe it gives you 36 for C. And then you just use law of sines off of that. Right? So you have the sine of 36 is to 24. Sine of 121 is to A. Sine 36 is to 24. Sine 23 is to B. What's nice with these types of scenarios, you wind up having to solve the same thing in the same position more often than not. So your button pressing kind of is the same. Yeah. So in this case here, I would just have to multiply by 24 and divide by the sine of 36. So I get 24 sine 121. Enter, divide by the sine of 36. I'm getting 34.999, so I'll call that 35.
Yeah.
Okay. Same thing on the other side, 24 sine 23, not 26. Divided by sine of 36, hit enter. I got 1595.
Yep.
Yes, ma'am. Okay. Always go 2 decimals. For everything, always go 2 decimals. Okay. And that's kind of my standard thing. And sometimes it might say nearest degree, but I just remember in the back of your head that means we've got the right 100. That one was 999, so it goes 35. Yeah, it was 34,999 something, so that's why I got the jump size. Yeah, it's one of those weird ones that happens. Okay. What else you got? Huh?
Yeah.
So this one's forced you to find angle B first. Again, start by drawing it out. We have A, B, and C. 154. Little b is 31. Little c is 44. So we have to find angle A, angle B, and little a. You are given angle C in the side opposite. Use that to find the other parts. Sine 154 is to 31. Sine of B is to 31. This case here, you just multiply by 31. I'm sorry, it should be 44 there. Sorry, that should be 44. I wrote too fast. So I do 31 sine 154. 31 sine 154, hit enter, divided by 44. Inverse sine of my answer, I get 1799. 154, 1799 gives me 171.99. Subtract that from 180, gives me 801. Do the same thing. Sine 154, 44. Sine 801 is to little a. So 44 sine 8.01 divided by sine 154 gives me 13.99. Yes. Can we round that through? What's up?
Yeah. I did that. And I divide by 4.
Okay, yep. This is the sine of that angle. So second sine of your answer.
Oh, okay.
Yep, on the angle. So what's up? You're the worst. Don't ever do that again. Freeland. Yes, sir. All right, skill check. Let's go. 8 minutes.
What's another? What's another?
Oh, you know what you're doing? You want to try it? You know what you're doing? Go make some mistakes. You don't know log cosine yet, do you? You've never had. Not yet. We'll be done with this unit next Tuesday. The first part of this unit is this stuff. Guys, we'll finish out with the calculator portion of the tray stuff next Tuesday, just so you guys are aware. Today we will knock out the ambiguous states. We're going to talk about that real fast, and we'll talk about log cosines. It goes by rather quickly because I know that you guys have seen it. You'll see real quick. All right. We have about 8 minutes. That's all we need. So we'll be done by quarter 2. All right. We'll go from there. Like I said, we'll get rolling through into good old ambiguous and finish that out. Anyway, on Tuesday, last Tuesday or 2 days ago, we talked about briefly signs and how you does sometimes work with what's called the ambiguous. Ambiguous case law of signs is when you have 2 sides and the non-included angle. We call it the side-side angle or the there's no S in math problem. So when we talked about this briefly on Tuesday, where I gave you guys that little bit of a hint in order for what happens. When you're given this idea of side-side angle, if the angle you're given is obtuse, you don't have to worry about anything. You're going to have one triangle. Okay? That doesn't change. If you're given, the only other thing that could happen is, in this case, if you're given the obtuse angle and the side opposite it is smaller than the other given side, then you won't have a triangle. Okay? Because remember, the largest angle has to have the longest side length, the smallest, and so on. Okay? That was a little short trick. The other thing that came about was when we talked about when you didn't have obtuse angles. Remember I said that you had all this other junk you'd have to check? Nobody wants to do any of this. This is a giant pain in the butt. There's no reason. That's why I showed you guys briefly what happens when you have 40-degree angle here. If this is 40 degrees and it flips to the second quadrant, the y values never change, do they? This is up 40 degrees. When you're off of the x-axis, whether it's up or down, however many degrees you're off the x-axis, it's always called a reference angle. Okay? That's something that's going to be really, really important here very soon. So if this is up 40, that meant that the angle coming across here was 140. And you guys saw that the sine values for both of those two were the same. You also saw the cosine values were the same. They were just flipped of the x, the negatives, okay? That was the whole trick. So what happens here is that when you have the angle side side, my hint for you guys is this. If the angle you're starting with was acute, you obviously have to find that second angle. When you find that second angle, automatically check its supplement. That supplement angle you add to the original angle. If you are below 180 degrees, that means you have two triangles. If you're above 180 degrees, you have one triangle, and just finish it. Okay? It is much easier to remember the idea that an angle in the first quadrant has a matching sine value in the second quadrant. So the side lengths would still work with an acute or an obtuse angle. And I have examples of how this looks here for you. For example, this may or may not be two triangles, I don't know. Again, what I want you guys to do is always draw the picture, fill in the blanks, and start looking at what you have. Excuse me. A, B, C, angle A is 20, little a, 10, little c, 11. That tells me right off the bat, I gotta find two angles on a side, so I write them down. I gotta find B, I gotta find angle C, and I gotta find little b. This problem is forcing you to find what first? It's forcing you to find C, correct. Okay. So, just like we did before, use what you're given as what I call a pivot. Sine of 20 is 210, as the sine of C is 211. Mathing of this is rather quick. 11 sine 20 divided by 10. 11 sine 20, enter, over, oops, sorry, put a parenthesis there. Over 10, hit enter, I get some crummy decimal. Second sine of my answer. It gives me an angle of 22.1. Okay. Everybody with me so far on that? Okay, just pressing buttons. Now, since this angle that I found is it's an acute angle, what I need to do is check and find its supplement. So off to the side here, I do 180. I subtract 22.1. And when I do that, I'm going to get what? 157.9? Now, for right now, this 22.1 and that 57.9, those two guys are the same, they'll have the same reference angle. They're the same degrees off of the x-axis. They're both 22.1 off the x-axis. That means their sine value will be the same. Okay? Their y value and the coordinate plane will be the same. What I do here is I'm just going to briefly call this C prime, because it's possible this could be a secondary triangle angle. Okay? So once I figure that angle, I take the original angle, which was what? A given angle, excuse me, 20. I add 20 to this. I get 177.9. Is that above or below 180?
Below.
That means you have? There you go. Yeah. So now what'll happen here is, I know that I have two different angles that can equal, that C can work with, okay? One of my triangles will be an acute triangle, the other one's going to be an obtuse triangle. The side lengths are going to still be the same for what's given to us. It's just going to be matched out differently with angle B. Okay? Yes, sir?
So if you have two triangles and you just go solve it.
No, I'm getting there. What we're going to do first is we're just finished solving what we have at hand. We figured out angle C. I'm going to use this 22.1, and then I do the 20. I add that together, I get 42.1, subtract that from 180, gives me angle B. Excuse me. So this is 22.1. Was it 137.9?
Yeah.
Okay. So it gives me angle B at 137.9. And then I do a law of sine again to figure out little b. So So sine of 20 is 210. Sine of 137.9 is 2 little b. Let's just make this calculator quicker. So let's see, that would be 10 sine 137.9, enter divided by sine of 20, hit enter, 19.6. Are we okay with that? So 19.6 gives me little b. And really all I can do right now with this one triangle is look and see, does the largest angle have the longest side length across from it? Does the smallest angle have the smallest? Medium work? That's really all you can do with that. But we know that there's a second triangle that can occur, so what we do is we just draw another picture. Okay? We draw another picture. The given information for us was angle A was at 20, little a was at 10, little c was at 11. Those three things will never change in the secondary triangle. What changes now is that we have this C prime. It's that second angle we've said that could possibly work. So now I call this one C prime at 157.9, which means there's a different B prime that can happen. And like you were saying, we just added those two together and subtracted. I think that was what the 2.1 for B prime. And then I just use law of sines again. Is 210. No, 2.1. Because 157.9 plus 20 is the 77.9. So subtract that from 180, so 2.1. And that'd be little b prime. The secondary triangles, extra side lengths you find, you just always reuse what you were given. And then the other three sides are just have these little, what we call tick marks for prime. It's a different value, okay? Because it's a different possibility. So then you just do 10 sine 2.1, enter, divided by sine 20, and I get 1.07. And once again, you'll notice the biggest angle has the longest side, the smallest angle has the shortest side. Right? Because in essence, what's happening here is you've got our one angle was what, 157.9, so that's like here. This whole angle here. And then it came over, the other one was 2, so that's a really small angle over here. There's the 2. And then this was across the C was the 11. This was that 1.07. This was, what was the other one? So one looks like that, whereas the other one was the original 20, we find it at 20, so something like that. So they still measure themselves out with these two angles, this value here and this value here, because if it matched up, these two values are directly across from one another, and that's why it works. Because there's that many degrees off of the x-axis. That's why it happens when you move things around to do that. Right? I'll never make you draw the double, because it's just silly. But the idea is you just draw a second triangle. Okay? It's not difficult because all you're doing is check my supplement. It's the easiest way to do it. I don't know why textbooks don't show it. All right? I don't know why. Yeah, right? All right, let's try another one. Try another one real fast before we get to law of cosines. Okay? Basically, I'm trying to get you guys comfortable with the process of checking the supplement. If you get comfortable with checking the supplement, the rest of it, as you can attest, is pretty easy. Using law of sines is one of the easier things we do in trig because it's the same process over and over and over again. Just make sure you press the buttons correctly. Okay. So here we've got angle A, little b. Uh, 70, little a at 155, little b at 160. Which angle is this forcing us to find right away? B. Oh, got to read my list. Angle B, angle C, and little c. Okay. Use law of sines real fast to go through that. We get sine 70 is to 155. Sine of B is to 160. So this will give us 160 sine 70 over 155. Inverse sine of my answer, I get 7593. Okay. From that, I'm just going to check and find its supplement. 180 minus 75.93. We get 104.07. We'll call this B prime just in case. What do I have to add to that? 70. Is that above or below 180? So how many triangles are you going to have? 2. So you just do the same thing twice. Okay. Your second triangle then, you have your A, your little a is the same. Your B is still the same at 160. This was 70. Your B prime is 104.07, which means your C prime would be different, which means your little c prime would be different. So basically, once you get past to here, you just basically just make the same triangle with the givens, put your prime there, and just resolve the rest of the other two parts. Okay, that's all you gotta do. Law of sines works really fast once you bounce it. And if that happened to be 17 or 181, that meant that just one triangle wouldn't have to do it. But anytime you do law of sines, you always check if the first thing you're finding is an angle. If you have angle side side, you always check to see if it's going to be two triangles out. Yes, ma'am. Yeah, because what you would do is you would just draw that out, and then you just do B prime and just make it on the list. It's the same thing. Okay. It becomes pretty evident when it goes through it. All right. Yeah. Yep. Yep. What's that? Yeah, it's regular B. It's regular B because you were given B to start with. Okay. So whenever all you're doing is you reuse the values that you're given with the other triangle. Because if I think about it here, this 10 value is still here. This value of 11 is just over here now because of the way the angles shift themselves. Okay. Obviously, it's not drawn this way. Now, the other thing that we will look at here real quick today was the law of cosines. Law of cosines is when law of sines doesn't work. All right. Law of cosines, if you recall from last year, is really just a ton of button pressing. Okay. And making sure you know how to work with the order of operations to solve an equation. So with law of cosines, you use law of cosines if you have side, 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 or side, angle, side. Because that means you don't have an angle and a side opposite. You use law of cosines to get a side and an angle across one another. Because you only use law of cosines once, because then it drops you to law of sines. Okay? I've made a decision to not make you, whenever you have to use cosines first, you do not have to worry about ambiguous case, even though it can occur. I'm not going to make you do all that extra work with the cosine problem because it gets really, really messy. Okay? Not like it's tough, but there's no reason to go that crazy. All right? So, for example, law of cosines, like I said, when law of sines doesn't work, textbooks, everybody always writes it out in terms of there's 3 different values because there's 3 different sides. Think of it this way. Notice the side and the angle opposite. Side, the angle opposite. Those are always on your ends. Everything else just replicates itself. You write it out a couple of times and it's super fast. Okay? Law of cosines is something that you guys will go through real quick. For example, if I start with something like this, A, B, and C. Angle B is at 38, little a is at 12, little c is at 16. Sorry, it's little b. When you look at that problem, when you draw it out, do you have an angle and a side opposite? Nope. Means you got to use law of cosines. That's why we say it that way. Okay. What side is this forcing you to find? B. Because you have angles B. All right. So you're using the angle that you're given, and these are just the other two sides. Does it matter which one's A, which one's B, or which one's C, honestly? Nope. So you know that your B squared will be A squared plus C squared minus 2AC cosine B. Well, fill in the blanks. 12 squared, 16 squared minus 2, 12, 16 cosine 38. And you literally type it in just like that. 12 squared plus 16 squared minus 2 times 12 times 16 cosine 38, hit enter. I get 97 and change. That equals B squared. What do I do to it? Second root of my answer, 9.87. Do you now have a side and an angle opposite? Yep. So you use law of sines. Here's the trick. Whenever you use law of cosines, if you find a side first, then you're going to use the law of sines after that. When you're doing law of sines, well, I told you more about the ambiguous. Always go with the largest angle first. It's just one of the things. So which of those two would you find first, A or C? Honestly, I told you not to worry about ambiguous. In this scenario, if you had to find a side first, it doesn't matter. It's when you have three sides that really matters. So, sure why. So from here, like I said, it's just law of sines, and it's what we've been doing. When it's sides, is when you have to be careful. When you're given just the three sides, it's really important to always find the largest angle first. When you do that, it kind of forces you out of having to ever worry about ambiguous. So you don't have to worry about ambiguous, but your numbers will be a lot cleaner. Always go the largest angle first and then find the next biggest angle and so on and so on. Right. Which of these angles is the largest? B. Remember, when you put your hands together, the further you open them up, the further apart the tips are. That's why biggest angle, bigger side. Okay. So now that angle B has to go, so I would have my, once again, the B squared is A squared, C squared, 2AC cosine B. When you think about this, you've got 18 squared is 8 squared, 13 squared minus 2 times 8 times 13 cosine B. These are addition parts, right? That's multiplying. That's just some crappy decimal. What do you have to move first? The addition parts. So right away what I would do is this. Just in my calculator. 18 squared subtract 8 squared subtract 13 squared. And I'm going to write that down. 91 equals, well, negative 2 times 8 times 13 is negative 208 cosine B. How do I undo multiplying by the negative 208? Divide. So 91 divided by negative 208, hit enter. I get some crummy decimal. That crummy decimal equals the cosine of an angle. Notice the cosine of this angle is negative. What comes first in the alphabet, x or y? X. What comes first in the alphabet, sine or cosine? Cosine. So if my cosine is negative, what quadrant is it in? Second quadrant. Which means what kind of an angle is it going to be? Obtuse. Second cosine of your answer, 115.94. That's why you get cosine values that are negative, because it's in the second quadrant, because your x value is negative in the second quadrant. because it's obtuse. I did 18 squared minus 8 squared minus 13 squared. If you think of it this way, when you're finding an angle on this stuff, guys, it's a two-step equation. That's all it is. Two-step equation with crappy numbers. It's really all. Okay. From there, what would I find next?
Anything you want.
And really anything you want, because you know both those other angles can't be obtuse. So they're going to be acute. So you automatically are away from having to worry about ambiguous. If you found one of the acute angles first, then you have to worry about ambiguous. By doing it this way, you don't have to worry about it. Yes, sir.
But like theoretically, what would happen
If you did it this way, I mean, if it did give you an acute let's say it gave you an acute angle up front, which it can, you'd still use law of sines first, and then you found the next angle, you bounce the quadrant. It is theoretically possible to have two triangles with law of cosine set up. All I'm saying is that I'm not going to make you do all that extra work. Because there's enough algebra here to satisfy. I'll only have you guys worry about two triangle with that ambiguous case. Okay? I won't force it into you on the cosines. It's not like it's tough. It's just, that's a lot of work. Okay? Do another one of these setups real fast before we get out of here? Okay. I'm assuming law of sines on this, you guys are cool with, right? All right, one more real fast setup. Again, same idea. So let's see, little a is 2, little b is 4, little c is 5. What's it for? What do you have to find first? C. Okay? It's forcing you to find angle C first. So you just write it out. C squared is a squared plus b squared minus 2 times a times b cosine c. And it's just calculator buttons. 5 squared minus 2 squared minus 4 squared 5 divided by, well, negative 2 negative times 2 is negative 16. And then I go second cosine of that answer, 108.21. And once again, in this case, I got an obtuse angle because I found the biggest one first. It's going to wind up being one triangle because you can't have two triangles. 5 squared minus 2 squared minus 4 squared and under divided by negative 16. And then inverse cosine. Yeah, make sure you hit inverse cosine. You guys have been doing so much inverse sine because a lot of sine stuff, you'll forget that this is a cosine problem. That's why you write it down, okay? That's why you write it down. In the 13.6, write down. Sheet over here. I wanted you guys to do this.
I brought page number names, but it's in 13.6. It's the cosine stuff. There's a section that I had you guys, I want you guys to do. It's on page 811, 30 through 37. It's a mixture of parts. It can be law of sines to start, it can be law of cosines to start, it can be a right triangle. It depends on what information you're given. So what's that, page 811, 30 through 37. There could be two triangles thrown in there. There could be a no triangle thrown in there. It could be a law of cosine to start. It could be a law of sine to start. And like I said, it could be a right triangle to start. Draw the picture, fill in the blanks, and you have to solve for 3 parts because they've given you 3 parts to start. Okay. The other thing is there's one other quick formula that we talk about on how to find the area of a triangle if you're just given the 3 sides. It's called Perron's formula. When you get into it, it's much, much easier to do something different. I'll show you guys that briefly tomorrow, as well as what we're going to do with problems like this. 2 scuba divers are 20 feet apart below the surface of the water. They see a shark. Oh no, it's below them. The angle of depression from one of them is 47 degrees. The angle of depression of the other one is 40. How far away is the shark from each other? In this picture, what do you need to draw? Triangle.
An upside down triangle. I like that. You got a triangle. You got 2 divers and a shark. So you've got your triangle, 2 divers, and a shark. So here's a diver. Hello. Here's Here's a diver.
However far away the shark is too close.
And yeah, right. Here's your shark. All right. How far apart are the divers? 20 feet. What's the angle of depression? Remember, my side looking down. Does it matter which one you put it? What are you trying to find? Trying to find those two distances. What would you use? Okay, because you have ankle side angle. Okay. Again, it's not like it's going to be really difficult. It's just a matter of can you draw a picture. Okay. That's what we're going to look at doing tomorrow. Okay. Yes, sir. What's that? I have it posted here in a second. I had to run down to the auditorium right at the first hour for a little lab thing, so I didn't get a chance to post it. Clinometer stuff? Geometry? You guys didn't do last year? Well, then never mind that.